Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video we will be discussing about natural language processing. So I hope that you are already aware about this specific domain. For those people who are not, please try to watch this video till the very end, because in this specific video I'm starting from scratch, considering that there are people who are not at all aware about this specific domain, and you will get a brief insight of what we usually have in NLP domain, what kind of data set we usually deal with in this specific domain. Afterwards, I'm talking about a very interesting discussion of large language models, GPT, how it works. At the very end of the discussion, I will also be talking about the GANs based architecture, how we will be able to generate synthetic data out of that. So all of these things I'm covering up in this specific video. After this video, I will release one more video in terms of practical implementation of whatever things I'm covering up over here. To watch that upcoming video, you have to first of all understand this as a prerequisite. This video is quite long. As a disclaimer, I am telling you. So if you are in a hurry, please don't watch it. But if you are relaxed and you have dedicated 2 hours for me, so please try to watch this till the very end. Document your learning. Try to share your learning in the comment section, what things you have learned. And also you can let me know whether you like these long form of videos or not, because I usually try to upload this because it contains the quality content, and because I'm teaching to the learners, so it brings that idea that, hey, someone is teaching to us in a very, very slow paced manner so that we will be able to learn everything. You can just let me know, and also please make sure, I'm again repeating, document your learning, share your learning in the comment section. At the very end, if you like this video, you have to definitely hit the like button, share this video with everyone. And now, without wasting any time, let me try to share my screen, and then we can start our discussion of what is NLP first of all. Natural language processing. It usually deals with a textual data. That's what you will observe, that it usually deals with a textual data. So depending upon the kind of data that you are using, your domain usually gets shifted. Let me give you a very simple example. A given use case might be that, let's say, you are saying that maybe your feedback will be, I really enjoyed today's session. Let's say this is the feedback of one learner. And another feedback is, I am bored in today's session. Now, if I just have to check, or now there can be two options to me. Maybe if I can have a team or I can afford a team, I will just check the feedback and tell me how many are the positive feedbacks and how many are the negative feedbacks. Might be I'm the person who is very much expert in specifically NLP specific domain. So instead of a person sitting over there and check individual feedback and then letting the CEO of the company knows, or the higher management knows, that how many positive or negative feedbacks will be there for a specific teacher or a mentor, maybe a bot is there who is automatically checking that how many are the positive feedback and how many are the negative feedback. Tell me, is that possible? Can a bot replace for this specific task as comparable to a actual human being? Can we do that? Yes or no? Is this feasible? Right in 2025. It's quite feasible, right? It's usually happening as well. So to understand the context and to understand the sentiment, to understand the feedback with respect to the customers, now it's a tech thing. So I'm talking about the today's session, but you can take this specific feedback in any other domain as well. For example, Amazon, right? We are purchasing the product and we usually provide the feedback of that specific product, whether it's good or bad. Now you can imagine that all over the world, people are consuming the product and they're getting the feedback. So if let's say any person is sitting over there, it's too much labor for him or her, right? So definitely a bot is there which usually tries to read the context and provide the summary of that specific data, that whether it's a positive, it's a negative, how much positive, how much negative, ratings will be provided as per that, and everything can be done nowadays very easily via the NLP. So same thing, same question. Yes, it is feasible over here as well, where this is something which our bot will say is a positive feedback, and this is something our bot will say will be considered as a negative feedback, right? So basically, to understand this specific data, this is something which is a whole string, which is very important to understand. And what this NLP domain or the models will do, it will try to identify the important keywords from the complete string. For example, to make it positive feedback, or to say or to conclude that it's a positive feedback, maybe enjoyed is the keyword. Can I say, everyone? Enjoyed is the important keyword to justify that whether it's a positive feedback or not, or to conclude that it's a positive feedback. Similarly, I would say in the second part, the board is the very important keyword. So it usually tries to pick the important keywords, which really helps the model to conclude that whether it's a positive one or it's a negative one. So because here we are dealing with the textual data, we need to process this textual data. That is where this NLP domain comes into picture. So it's a very simple example, or I would say a simple use case to understand the domain of NLP and at what point of time this specific domain comes into picture. Is this part is clear to everyone before we will proceed ahead? Any doubts over here? Any doubts over here, anyone? Or we will move further? I really need the energy to be high. So can I get the confirmation from everyone over here, so that I'll get to know that no one is sleeping in my class? Ravi Teja, this is not something which is supposed to be done by me. You can request the same thing to the PW team and they will help you to get sorted, right? Perfect. So let's move ahead now. Currently, till so far, we have understood that, how the complete NLP domain usually works and surrounded by which kind of a data, right? That's something which we have covered up for now. Now, this is not something which is a very easy step. Why is that so? Why is that so? Why I'm not saying that it's not something which is an easy step? What is the issue in this specific pre-processing part? Anyone who can just let me know? So what we are saying is that there is a bot, there is a model which helps to give a conclusion that the first feedback where a learner is saying, I really enjoyed today's session, is a positive one. And the second feedback where the learner is saying, I am bored in today's session, is a negative feedback. So my question is, what I'm asking from you all, that it's not something which is a easier step. So why I'm saying so? What is the issue when our model processes this specific string of I really enjoyed today's session? What is the issue? Anyone having any answer? Any guesses? It has layers, textual tokenization, lemmatization, followed by stemming, etc. Also, associations and understanding of these tokens are required. Have to do pre-processing a lot to catch the emotion, okay? Uh, yes, that's true. That's true. But when we are saying data pre-processing in a I would say textual string, so these layers are fine. This is something which we have to do at the end of the day. Tokenization meaning that we are trying to split our words, maybe with the help of the spacing. So we will be having I really enjoyed today's session, maybe in the form of a list or a dictionary or a set, right? Maybe let's say in the list we are trying to store our data. So we get the tokens, we are trying to apply the lemmatization or the stemming for the same. But that is not something which I'm talking about over here. What I'm saying is when we're passing these words, these tokens to our model, what do you think? Does our model will be able to understand the meaning of this specific data, this specific textual words? I think in our last discussion, when we were talking about ML things, we have talked about this specific point that the models won't be able to understand the, are you getting my point? Textual data. So, what is the important step which we're supposed to do as a part of pre-processing so that our model will be able to understand the entire data? Any guesses now? No, no, not tagging. Not tagging. What is the most important part which our which as a uh, you know data scientist we have to make sure we have to do so that our model will be able to understand what data we are feeding inside that? We all know that the model won't be able to understand this textual data. Conversion of data. Yes. In which specific format? Stemming is done. Let's assume stemming is done. That we're tagging with respect to the appropriate, whether it's a noun or all those stuffs, it's fine. Now you're reaching to the exact point, everyone. So this is what I was talking about. After doing the basic stuffs, I'll call it as the basic stuffs, whether you're talking about stemming, lemmatization, tokenization, removal of the stop words. All these things are the basic steps. But after doing that specific steps, the most important step or the most crucial step which comes into picture when we are working with this specific domain is embeddings. Embeddings. And that is something which is really important to understand if you're working in the space of NLP. So what is the meaning of embeddings? Embedding meaning is to convert the textual data to vectors or to the numeric form. So let's assume we will be having a textual data. How can we convert that specific textual data to a vector form, right? That is where the embeddings comes into picture. That is the process of what we call as embeddings, that we are converting our textual data in the form of a vectors. Vectors meaning in the form of a, I would say, numerical representations. Quite fine, everyone. Now, this is where a very famous embedding, which I think everyone must have heard of, called as word to wake. If anyone is not aware about this specific algorithm, how it works, please try to have a revision or the brief walkthrough after this session will get over and try to understand that how this embedding will work in detail. Brief context I'll provide you in the session itself. So this is one of the very widely used algorithm, which is specifically being designed to convert individual words or the tokens that we will be having into a specific vector. How it is being done? Let me give you one simple example. For that, let me try to fetch a snapshot. There is a very famous example, and I'm pretty sure that you must have heard of this specific example, where uh, you must have seen that when we apply king minus man plus queen while applying the word to vec algorithm, automatically we were getting the result as, sorry, plus woman, we were getting the result as queen. So how is this possible? How this subtraction or addition operation will be done in this specific world of textual strings? This is possible because all of these specific textual data points that we will be having will be converted to the vectors form. Now we have to understand what is the meaning of vector and how this conversion usually happens. For example, let's say we are saying that we are having multiple features of king. Maybe what is the gender of, let's assume, what is the gender of uh, the whatever be the feature you are using, right? For example, let's assume -1 represents a male gender and 1 represents a female gender, right? Similarly, let's assume that this is whether the king is rich or not, whether the king has a tail or not, whether the king has authority or not, uh, whether the king is poor or not. So let's assume here again, whatever be the values I am writing over here, all are the assumptions for now. But that is for just for your understanding per se, that for every specific, uh, you know, textual data that we will be having, we have the features of that specific data points that we are working with. For example, with respect to king, we have multiple values, multiple features, and depending upon whether they will be having that specific uh, entities available with them, it will be either marked as 0 or 1. For example, king is having authority, king is rich, king is having a male gender, it's not poor, it's not tail, so we are assigning the value as 0. Similarly, for a man, maybe similar thing will be assigned, same values, same features available with us. Same thing we will do for women. So when you will get this value for a king as 1, 0, 0, 1 and -1, this is what we called it as vectors. So when I'm saying the word to vec will be converting the specific into numerical vector, this is what we called as numerical vectors. Now, with the help of this kind of a conversion, it will be able to understand the context or the meaning of that specific vector as well, which indicates that now the king is having a male, king is having a authority, king is rich, but is not poor and has not having any tail. So that is how the conversion usually happens. And we already have the vectors available for all the textual words, tokens that we will be having. And when we are doing that, do the operation like king minus man plus woman. So it will not be like that this textual strings will do any operation. Internally, every textual string will be having its vectors available. And actually, if you will be able to observe, these vectors are doing the operations, and when these vectors will do the operation like 1 minus 0.2 plus 0.2, getting the answer as 1. 0 minus 0 plus 0, getting the answer as 0. 0 minus 0 plus 0, getting the answer as 0. 1 minus zero point 0.3 plus zero point 0.2, getting the answer as 0.9. Minus 1 plus 1, getting the answer as plus 1. So now our, once we will be able to get this 1, 0, 0, 0.91, it will be compared with what is the closest numerical vector that we will be having in our dictionary. And this specific vector, which is 1, 0, 0, 0.9 and 1 will be compared with the queen, which is having a higher, or I would say highest similarity, which is having a highest similarity. And that is the main reason why we're getting the answer as queen. Is this clear to everyone? And that is how it is captured in the meaning of a given sentence, whatever is available with us. Any doubt till so far? Anyone? That is the main reason. You will see several examples available on the web. Maybe I have fetched few of them. Let me showcase you this example as well. So you can clearly observe over here that this is how the embeddings will be done, where mathematics and stats usually belong to similar context, and that's why they might have, they're very close to each other because they will be having a very similar numeric vector representation, whereas tiger and lion, they are belonging to similar context, and that is where you will always find that they're very near if you will try to plot it and check it, because their numerical vector representation is almost similar. That's the whole idea of word embeddings, which plays a very significant role when we're talking about NLP domain. Is this clear to everyone? The context behind embeddings and why it is important? Now, always remember, whenever you're entering any token, any word, it is always being converted into its numerical vector. And then the operations will be applied. Before that, no operation will be applicable because it won't be able to understand the meaning of that specific textual data itself. So what it will do, right? That's the whole idea. Is this clear? Shall we move further? Now, it's not like that we just have word to vec as a technique. You will find several models apart from word to vec as well. For example, there is a model called as glove, right? Fast text. All these are the examples which people usually use to get the, I would say, embeddings done. But this is something which I would say is very widely used till so far. What happens when we use sarcasms in sentences like, oh great, another fantastic movie? Negative sentiment, but using a positive word sarcastically. So, for this specific context as well, there must be an emoticon. Like, otherwise, your model will definitely get confused because just by looking into this specific string, even as a human being, if I'll not capture your expressions, if I'll not capture your tone of saying, and if you just say to me that, oh, great, another fantastic movie, I will also mark it as a positive sentiment, isn't it? Until or unless I won't read your expressions, maybe if we are talking to each other physically, or if you are just providing me, if let's say we are doing a WhatsApp chat or any other chat, in that case, you have to provide me the emoticons with that specific part. That's why if you will be able to observe in all the chats, in all the social media platforms, even on LinkedIn, emoticons are being provided. The main reason was that whenever someone is working on textual data and that specific data is being fed, if someone is saying sarcastically, they have to provide some sort of expressions over there so that internally our model will be able to understand that, hey, it's not something which is a normal string, it's a sarcastic string. So that is where your data feeding comes into picture. And if your data feeding will be appropriate, then only you will be able to get the appropriate answer, which is negative sentiment. Otherwise, definitely you will get a positive sentiment only as the answer, because there will be always an ambiguity in this specific case. Your name is mentioned as iPad, so I'm calling it like that only. Again, ambiguity. So is this clear to you? What I'm trying to convey over here? Perfect. Shall we move further now? Is everyone comfortable till so far? I'm expecting that no one is feeling that she's just talking about jargons over here. Is this clear till so far? Everyone is comfortable? Yes or no? Can I get the confirmation? Any doubts anyone is having? No doubt. It's very good. Now, after this embedding, uh, what happened? Researchers faced another trouble. And what was that trouble? So, with the help of these embeddings, the issue of that capturing the context is resolved somehow. Because now you can see from this diagram as well, because of this numerical vector representation, words will start capturing that specific context, and because of which problems start getting resolved. And that was the time where, again, the boom of NLP was there. But then they thought that why not to work on the bigger sentences where, let's say, the problem of language translation, people, let's say, might just be aware about Hindi language, and they're traveling, and let's say they're traveling to some other city where people are not aware about Hindi language. They just know English or any other their own regional language. So how one language translation will be done to another one? Initially, Google comes up with their own researches, and they have made that Google translation open and accessible to everyone. That was the time where the results were not appropriate by the model, because although the context will be covered up in these embeddings, the issue was that as and when the sentences will become long, it's quite difficult for the models also to you know store that specific results of the embedding so under their need, and they won't be able to get that conversion done because they won't be able to retain that specific memory. And that is where the origin of what we called as transformers and attention based models comes into picture, which resolves this specific problem. And after the generation of that specific model, there is a huge boom, and the models start behaving very smartly. You will see that how matured nowadays our Google translation is. Whatever language translation you want to give, how longer sentences you want to give, it will be easily able to convert that specific sentences to other specific programming, or not programming, any other specific language, and we will be able to get the results very smoothly, right? And that is where the transformers, or I would say the attention based models, comes into picture in the space of NLP. So I'm talking about the problem, and then I'm talking about the solution in a storytelling manner, so that you all remember that uh, what actually was the issue, and to resolve that issue, what actually researchers have done. If you will try to learn like this, at least when I learn, I usually learn like this story manner, because of which I will be able to retain the things in a very easier manner, right? Because there is so much in every space, and if you will not try to learn in a appropriate manner, then you will easily get forget you easily forget these things, right? So now, when transformers comes into picture, what is that, by the way, transformer? You will be able to observe, although I think you already have learned about this specific part yesterday, so I'll not deep dive into it about the architectures. But let me give you a brief context for all those people who really struggling about this specific part. What at the end of the day we have observed is that it's nothing but is an encoder decoder kind of architecture. Yes or no? Yes or no? It's an encoder decoder kind of a architecture, right? This is the important thing. And we all know that when we talk about encoder, it is somehow taking the input values. And when we talk about decoder, it is somehow giving us the expected output, expected desired output, right? Now, when this specific architecture was initially developed, so there are multiple types of results which we usually start getting, multiple different types of models or the use cases we will be having. For example, the use case like many to many, which I was just talking about, What is the meaning of many to many? That we have multiple input values and we have multiple output, which is a language translation model. Right? In which, if let's say I'm saying that, let's say, how are you? So if it is three specific tokens available, with respect to every token, we are getting the response. So this specific value will be fed inside the encoder specific architecture. And as a decoder architecture, we are expecting that it should give us the answer as tum, let's say, kaise ho, right? So what we are expecting is the multiple inputs and the multiple outputs over here. There can be other specific use cases also where transformers would be easily able to solve the problem. It may be a many to one to many, one to one, and many more. So depending upon what kind of use case we are trying to solve, we will be able to get different kinds of architectures available with us, right? To get, if you will ask me that, Priya, if I just want to more dive into this specific architecture, what are the best resources you know till so far, or what are the resources you personally refer whenever you want to work on this specific architectures? So I always say that when we talk about transformers, the very first thing, the research paper that we have, for example, everyone knows, right? Attention is all you need. It's the authentic research paper of, I would say, transformer based architecture, where the complete architecture you will be easily able to find out, right? Apart from this, if you want to refer any of the freely available resources, if you will ask me any free resources which you can recommend to us, which we can refer and try to more dive into the specific architecture, because one thing which you always have to make sure, if you will ask me what is the most important topic in the NLP space, which specific topic is the most recommended, most important, where I should spend the maximum time if I want to become an expert in the specific space, I would say this is the topic. This is the topic. This is one of the, I would say, core topic of NLP, because whatever architectures we usually today we are using, maybe GPT, maybe BERT, if you will be able to observe, all of those architectures comes from transformers only. If you will ask from me what is the full form of GPT, any answer? What is the full form of GPT? Whatever GPT we are using, GPT 3.5, GPT 4.0, what is the full form of GPT? Any answer anyone is having? Any answer? Anyone? Full form of GPT. Generative Pre-trained Transformers. So at the end, again, can you see the term? Transformers. So if you will see the literal maths behind all of these architectures which we are using nowadays, it's nothing but transformer based architectures only. So you should know that how the encoder will work, how the decoder will be able to generate the output, what's the internal maths behind that and everything. Now, I'm not sure how much depth you know. I'm not sure how much depth have been covered up in your live classes and in yesterday's live session, but I can give you the personal recommendations of the resources which definitely you can refer, even though you already aware about this specific concept. I am pretty sure that you will learn more things on top of what you already know. And I was just opening before this session. These are the resources. How many of you have heard about J. Elmer and his channel? Again, it's not something which someone has said to me. It's just that when I started my journey towards learning this specific architecture, I really find his blogs very easy and understandable manner. So here you can see completely he has explained about a high level look, and then encoders, decoders, the example which I was giving to you, the language translation example. Similar kind of example, I think he has picked up to explain the specific concept, right? So if you will take the things step by step, you will be able to understand each and everything in a lot more detail. Even I think he is also having the YouTube channel. Let me try to share with you the link for that as well. Just give me a second. I'll open first of all. So 4 years ago, he has uploaded the video, but I think still this video is equally valuable. And this is the video uh, which I personally like, and I will definitely try to share with you guys so that you will be able to get the better understanding of what are transformers. Yes, GPT blog is also very nice, and even the GPT video, I'll share that as well. But for now, maybe you can bookmark it somewhere, especially for those people who are listening for the very first time about his work and his blogs. You can bookmark it somewhere, and then maybe once the session will get over, maybe tomorrow, day after tomorrow, whenever you feel that you have a time, you can always and always go back and check this blogs and the articles and the videos, and definitely you will thank me later about this specific resource, because I personally like it. Initially, when I started the learning of this transformer based architecture, I refer multiple resources, I refer multiple videos at my point of time. But today also, when I want to revise this the architectures and everything, so I directly went to the specific channel and you know give a one time review of what he has explained, and the thing is done. So the same thing you can do at your end, and you can let me know maybe in the upcoming session that whether whatever I'm saying, you also feel the same or not, right? So this is the overall discussion about the transformer. Now, once the transformers comes into picture, afterwards there are architectures like BERT and GPT, which takes a boom. Apart from this, one important thing that in all these architectures, whether it's a transformer, it's a BERT, it's a GPT, there are the beauty about today's world is that we will be having the pre-trained models available with us. So all the new startups working in different use cases, working in different problems. The good thing why those startups still continue to run is that somehow they know that when they will hire someone to build any specific new model, they can use those pre-trained models. So what is the meaning of pre-trained models? Anyone is having any idea? For example, if let's say you will search for maybe transformer pre-trained models, you will see this hugging face. And here you can find out there are several models that we will be having, in which you will see the detailing of each and every model, and different architectures we will be having for BERT, for GPT, for GPT-2, for transformers, Roberta. All these are the different models that we will be having. And we will be having the pre-trained models available with us, which we can use at any point of time in our work to execute our task. And on top of that, we can train our model, or we can fine tune our data set. So there are two words which you will find quite heavily being used in the industries: pre-trained models, and the second word is fine tuning, which I have just now used. So how many of you knows the meaning of these two words? Yeah. How many of you knows the meaning of these two words? Firstly, let's talk about pre-training. So when you heard this specific term, pre-training of any specific model, always remember it means that the model is being trained on very huge amount of data. very huge amount of data, right? And it might requires a good GPUs. It might require, uh, you know, a lot of highly configured systems to train that specific model. And now this is freely accessible to everyone. Everyone can use that specific pre-trained models. And on top of that, let's say your task is something which is different, but somehow that specific pre-trained model will help you to build a strong model. So what you can do is you can fine tune your own data set that you will be having, and you can work on your task. So that is what usually we are doing. For example, I remember in my college when I work on my project of NLP, same thing I have done. I have used the pre-trained model, and top of that, I have done the fine tuning. Similarly, in the company work, whenever I require the need of GPT based model or transformer or BERT based model, I directly go to the documentation, picked up the pre-trained models, which I see that this is something which is equally valuable for my task. On top of that, I'll do the fine tuning. So that is how the complete flow is usually being done, right? So yes, that's true, which Ankit has said. The model which is being trained on massive amount of data is something which we call it as a pre-trained model. Why we should not always start from scratch in the domain of NLP whenever we're working with any new problem? The issue is that we don't have that much resources available. If let's say today I'm working on a new project, so as an individual, I don't want to invest too much money on purchasing maybe a good, highly configured laptop. There's a lot of investment which is usually being done, right? So that is the whole and sole reason that companies also, especially startups, they don't want to invest. Maybe the companies like Microsoft, Google, they have a lot of fundings available with them, right? So they can do the investment, and that is why you will be able to observe any new model, any new pre-trained accessible model, they are backed by these companies. And even if it is a startup, if you will check, the backend funding is given by these specific companies because they are heavily investing on these specific stuffs. So that's the whole point, and everyone is somehow using that specific thing to train their own use cases, right? You must have heard of the example of Dr. GPT. How many of you have heard? So once after the coming up of the chat GPT, people started, or organizations started working on their individual GPTs. Companies have their own GPTs available with them, where they can load their own personal confidential data, because on an open source system, everyone can't afford to load the data. For example, if let's say it's a patient data which is being used by doctors, it's not advisable or it's not authentic, it's not right to upload that data in an open source environment. And that is where what companies have done. Companies have tried to create their own GPTs available with them. And how that creation will be done? They have used somehow those pre-trained GPTs available itself. On top of that, they have used their data set to create their personalized GPTs available with them. So that is the whole idea which I really want to give over here. Is this point is clear to everyone? Shall we move further to the next important point? Yes or no? Now, when we talked about BERT, I don't know how many of you have uh, understanding of BERT, but there is a very huge difference between BERT and GPT. When we talk about BERT, it's a collection of any guesses, and GPT contains a collection of only decoders, and it is a collection of encoders only. So basically, if you will be able to observe, when we talk about BERT, if you will see the full form, as many of you have mentioned, bidirectional encoder. So basically, when we talk about transformers, it's a combination of encoder plus decoder. But if you will just take the encoder over there and want to build something on top of that, that is where BERT is the architecture which is being designed, or which the naming convention is being given. And when you take only the decoder part, the GPT is something which is the model name which is being conveyed over there. Now, what are the applications of GPT and what are the applications of BERT? Different models of different purposes. For example, if we'll talk about GPT, basically, as the name itself suggests, generative pre-trained transformers. Whatever task you are seeing nowadays, which is basically used to generate the context, to generate the textual data, to generate the data itself, that is where GPT based models comes into picture. So any specific task where you will see that a text generation is being used, maybe you will see a text summarization is being there. That is where the application of GPT lies. When we talk about BERT, any guesses? What are the use cases or the examples of BERT? Have you ever heard of where this kind of architecture will be super helpful? Yes, if you want to do a text classification, right? Q&A. In all those kind of instances, BERT plays a significant role, right? So this is the overall idea about BERT and GPT. Now, before deep diving into it, these two aspects separately, generation of a text, how it will be done, and the classification, how it will be done, let me talk about something called as the concept of language models, because this is very important to understand so that we will be deep diving into this specific context. So, any idea what is the meaning of language models? You must have heard of that chat GPT is also called as LLM, large language model. So the last two words which you usually heard of, LM, language model, that is what I'm asking from you. What is the meaning of that? What is the meaning of language models? Any guesses? Any idea? Okay, so someone is saying it is to predict next word. Yes, somehow it's true. Any other answer anyone wants to give apart from what Basant has said? An ML model trained on large data to understand, generate, and manipulate human language. That's true. That's true. Very good. Any other answer anyone wants to give? Any other point which anyone wants to add apart from what these two people have said? So, in a language model, that's true that the main task you will be able to observe is to, I would say, do the prediction of the next upcoming words based on the probability, right? For example, when we talk about these GPTs, if you will be able to observe over there, in this specific GPT world, the very first context or the very first thing which is being done internally is the unsupervised pre-training. What is the meaning of that? For that, let me insert one more image, which I think you can see, right? What is the meaning of unsupervised pre-training? The simple meaning is here, if let's say we will be having multiple words available with us, so what will happen is it will try to split that complete sentence into what we called as tokens. So individual word is a token. Second, law of robotics, and then colon. And this A is something which we called as is a next word, which is kind of a label data. So what is usually happening is that a training will be done where we will be having the multiple words available with us, and the label data is the next instant word available. So like this, second law of robotics colon, the labeled word is A. Second law of robotics colon A, the next expected word is robot. Second law of robotic colon A robot, the next specific labeled word will be must, and so on. So this is how internally what usually happens is that our complete data will be trained based on what is the next predicted word, next outcome, next word based on the previous words that we will be having. Right? So once this training will be done, this is what we called as what we are doing over here, unsupervised pre-training. And this kind of unsupervised pre-training will be done on a very huge amount of corpus of Wikipedia, wherever the lot of data will be there. And because of which, once the training is done, you will be able to observe that whenever a new data point will be entered, it will try to predict that what is the next expected word. I hope everyone have seen this application. Nowadays, it is almost everywhere. For example, whenever you're writing a mail, how many of you have observed that once you write a single word itself, for example, let's say I'm reverting the mail and I'm writing, hello Priya, I hope. Automatically, it is giving me the answer, you are doing well. How many of you have observed this thing? Automatically, it is trying to give me the prediction that this is where the next specific word should come. Yes or no? Have you ever observed this? This is not something which was there prior. I think we used to write the mail from back in, I think, 10, 15, 20 years back. I'm not sure about you, but at least we have seen, right? We have observed. It's something which is happening from past, I would say, few years, where this generation of these GPT based models comes into picture. And after that only, that kind of, I would say, functionality is being there, where in a document, in a Google document, if I'm just writing a single word, I'm getting the upcoming words and I just have to apply a tab button, automatically that will be entered. I hope you have seen that, right? This is only being done with the help of what we call as GPT, what we call as this unsupervised pre-training, which is being done on a very huge amount of data. So if I'll just try to pick up the next specific image, it showcases that how this specific thing will be done. So these are the features that we will be having, right? For example, this A, robot, must, it is being usually passed into the GPT-3, which is under training. It is just having a pre-trained data available with us. It will try to give the next prediction. Let's say this will predict that next word is troll. But actually the correct output, the label data says that a robot must, the next output should be obey. So what will happen is it will try to find the error. What is the error? I hope everyone knows now. This is something which is the actual data. This is something which is the predicted one. So what is the meaning of error over here? Tell me, what is the meaning of error over here? This is nothing but is a difference between actual and the predicted. So it will try to do a measurement in the form of numeric vectors itself, that what is the actual error we will be able to get over here. And with the help of this error, now at the end of the day, when we are saying we are training our model, we are doing a training, our main purpose is to reduce this specific error. Main purpose is to reduce the specific error. So what will happen over here? What will happen over here? It will do a backward propagation. Same concept that we have learned in our neural network classes. It will go back, again, will try to update the weights, and it will again try to give the next expected result. It will keep on doing this specific training till the point it will reach to a point where the error will be approximately equal to 0. Optimizer will comes into picture to reduce its error to the global minima. Global minima in this case will be where our output prediction will be exactly equal to obey. Is this clear to everyone? Now, how this specific next expected word which we are getting over here is working? Any idea? What is the real maths behind this? How my model will be able to say that a robot must, the next expected word should be troll, even though it's not correct, but how internally it is giving me the specific output? Any guesses? Anyone? What is the maths which it actually uses, this complete generative pre-trained transformers or the language models? What is the mathematics which they usually use to predict the next word? How many of you knows? How it is saying that, hey, troll will come. Then it will try to compare the actual output, and then error will be calculated, and then the again backward propagation will be there. Again, training will happen. But my question from you all is that how my model will get to know that the next output prediction should be troll? What real maths are they using? First of all, whatever points we have covered up till so far, is this clear to everyone? Or are you guys feeling bored in the session? Can I get some confirmation? Till so far is everything is clear, because we are jumping towards the next stories. It is very important to take a pause and just have a brief recap of whatever things we have covered up and whether it is clear or not. Can I get some confirmation? So what we have covered up till so far? We have talked about what is this domain of NLP is all about. We have talked about embeddings, how it will be helpful to generate the semantic values or the contextual values of the textual words. For example, this how it will be able to give me the result as king minus man plus women as queen. How it will be able to do the conversion towards the, I would say, numerical values, right? Numerical vectors. How this mathematics and statistics are very closer to each other, and tiger and lion are very closer to each other. What's the real reason behind that? Transformers, I have tried to share with you the resources. After that, BERT, we have seen its collection of encoders from the transformers architecture, and the collection of decoders is what we have is GPT, their use cases. And after that, we have seen the meaning of language models and what is the meaning of unsupervised pre-training and how it is being done. Is this clear till so far? Whatever points I have covered up? Anyone having any doubt with respect to whatever points we have covered up over here? Yes, clear, very interesting. What about others? If at any point of time you feel that something or some point is not clear, you can just pause me over there and you can just let me know that, hey, you just have to repeat this specific point so that I will take a pause and first of all repeat to that point, because if you will be able to observe whatever topics we're covering up today, it's a kind of a continuation of the previous story. So if you missed any one of them, then the upcoming story you won't be able to get it in an appropriate manner. That's why I have taken a break over here. Shubham, please go ahead and ask your question if you have. In the meantime, I hope everyone remembers my question. I told you, what is the maths this GPT is using over here to predict the next specific word? That's the question which I'm asking from everyone. So if anyone is having any answer over here, any guesses, you can just let me know. How we are going to use this stuff in data analytics domain. Maybe Shubham, just wait for next 10-15 minutes, and then maybe I'll answer this specific question. Let me complete this specific point, and then maybe we can move ahead with this specific question. Yes, any guesses? Logics and then softmax is applied. Okay, but when I'm saying mathematics, can you give me the name of what specific maths, what specific topic is actually required to understand over here to get that next expected word specifically in GPT context? That's my question. Probability. Yep, that's the correct answer. In probability, do you know what specific probability we should know to have a clear cut idea about the specific concepts? What specific concepts of probability we should know to have a clear cut idea about the specific concepts? I think now you guys are approaching towards the right point. It's not distribution, I would say. It's a concept of conditional probability. So how many of you knows the internal intuition behind conditional probability? Uh, I'm pretty sure that you must have encountered this specific probability part in your work, or maybe if not in your work, in your classes, in your lower classes also, and in your college specific work part as well. If you have the subject of discrete mathematics or engineering mathematics, this specific topic is very, very important in machine learning algorithm, where we usually refer naive Bayes algorithm, the complete Bayesian theorem and how it works. And in this specific context of NLP as well, where what it says is that why it is called as conditional probability, it says that depending upon one condition where one outcome is already being done, what is the probability of next outcome? So, in this specific context, if I'll just have to explain to you, it will try to evaluate, for example, if let's say this is W1 as the input value, W2, W3. So, given these three words as the input value, what is the expected output, which is W4? So, what is the probability? What is the probability of W4 given the value of W1, W2, and W3? It will try to evaluate that specific thing. That's the whole idea, right? So it will try to evaluate what is the expected probability of W4 given the value of W1, W2, W3. How many of you knows, if I'll say what is the probability of A given B, how we usually evaluate that? What is the formula to evaluate the probability of A given B? The way we pronounce it, what is the probability of A given B has already happened, right? So anyone having any answer, how we usually evaluate this? What is the probability of A given B? So it is nothing but what is the probability of A intersection B divided by the probability of B. Right, everyone? Is it correct? And probability of A intersection B can be written as probability of A into probability of B given A divided by probability of B. It's one and the same thing. So you can write this also as probability of A into probability of B given A divided by probability of B. This is actually a way to evaluate the conditional probability. How it actually comes, if you really want to go in a bit more math, so you can also write probability of B given A as probability of A intersection B divided by probability of A. So what we have done is we have just done the cross multiplication. So probability of A intersection B is nothing but what is the probability of B given A into the probability of A. And this is how basically we have tried to just replace this probability of A intersection B with this probability of A into probability of B given A divided by this specific term. So this is how basically we will be able to get the result. So what it usually does is it will try to find out that what is the probability of, let's say there are multiple expected words in the output prediction. So it might be the case because it is giving us the answer as troll. It means that might be the probability of troll given the feature A, robot and must be very, very high as comparable to other, I would say, possible predicted words. So that's the whole thing. It might be the case that the probability of troll given the input values as A, robot and must, it is clearly indicating that this probabilities might be very, very high as comparable to other possible words like obey or whatever be the expected words we do have in the dictionary. It will definitely try to evaluate the probability of each and every expected word, and whatever is having the highest probability, that is where it will try to give you the expected answer. That's the whole point. Is this fine to everyone? So far, so good. Shall we move further? So this is the story about language models, which is what we have discussed. Now, when we talk about the platforms like ChatGPT, which is able to give us a complete result, the models like Perplexity, Claude.ai, we call these models as LLM, which is nothing but large language models, not the language models. We call it as large language models. Why is that so? What is LLM? Now, if someone will ask you, why is that so? What is called large language models? Language models meaning that, okay, internally somehow they are working on predicting the next specific word using that unsupervised pre-training mechanism, using that conditional probability part to get that next output. And this is how basically we will be able to get the complete sentence as an output in the language models like ChatGPT. But why it is called large language models now? You always have heard of LLM, not LM anywhere. What is the reason behind that? Very good. So, as mentioned by Anvesha, it is being trained on huge data set. And because of their huge number of parameters, which is what we call as weights, and the massive amount of data, it is called as large language model. So, large is being mentioned just to do the emphasis that the training is being done training is done on a very huge amount of data, on a very huge amount of data. Okay? That's the main reason why it is being called as a large language model. So is this clear now? If in future someone will ask you what is LLM, will you be able to explain step by step meaning of language models and then meaning of large language models? Yes or no? So far, so good. Yes or no? Is this clear till so far? Hmm? Yes, perfect. Now, this is the story about textual data. But nowadays, you will be able to observe that we do have a concept of images, right? Where we will be able to observe that the tools are so much mature that they will be able to generate the images as well, right? So that is where the models like GANs comes into picture. Generative Adversarial Generative Adversarial Networks. How many of you have heard about this specific term of GANs? So we'll talk about that specific part as well. But before that, I'll give you one more interesting part that if you want to deep dive into this internal working of GPT-3 again, refer this channel. He has explained this specific topic also with animations and a lot more great detail. Again, the blog is also there. This is the blog, I think, with respect to the generative models, right? And how it works. I'm sharing again this back in the chat window. Please, this is the task for today's class to everyone, that just have a brief a recap of whatever points we have covered up via this his videos, and you will definitely able to get a better understanding of what you got right away right now, right? So after, once the session will get over, refer his blog and YouTube videos, because it's a live session. I'm not showing any kind of animations or the presentations over here. I'm trying to explain you in a very layman manner, and now I feel that once the session will get over, you will be having the understanding of all those concepts, right? Whatever we have covered up today. But if you want to just give a more, I would say, structured manner understanding, maybe let's say if you are getting 70% or 80% from this specific session, pending 20-30% you will be easily able to get once you will be able to see those animations, those videos. So this is the task for today's class. Okay. Now, let's talk about this GANs. And for that, let me try to insert the architecture of this specific part. Very interesting, at the same time, very widely used to generate the images. So here you can see that we will be having this two, I would say, blocks over here. One is called as generator block, which you can see very clearly. And the another one is called as discriminator block, right? Generator block and discriminator block. So what we are doing in this specific world of GANs, we are trying, first of all, we are trying to use this specific concept of GANs where most widely the images are not available. For example, I'm not sure how many of you have worked with healthcare specific domain, but in that specific domain, you will be able to observe that there are a lot many use cases, there are a lot many problems where data is not enough, right? We need more data. And whenever we have these kind of use cases where data is not enough, whatever training data we have, whatever real samples we have, so in that case, we need to generate the fake samples or fake data points in such a way that those real and fake looks almost similar, so that when we feed those specific samples, those specific data points in our model won't get that understanding that is this real or is this fake. So to train or to generate those kind of images, that specific kind of data set, you will be able to see this specific architecture, where what we are doing over here, we are having this training data where we are having the real samples. Then we have this random fake data points available over here, which will be able to generate this fake samples. Now, the purpose of this discriminator is to differentiate between this real and fake. Now, initially, when the fake samples will be generated, obviously the loss, the difference. So this is something which is the actual value, you can say. This is something which is the predicted value. What we want is this actual and the predicted, the real and the fake should look almost similar. Means the gap between this y and y cap in terms of the given images should be approximately equal to 0. And that is where I would say that the error is minimum. Error, or you can say the loss, right? Error, or you can say is the loss is minimum. Yes or no? Now, initially, obviously, when we are starting our training process, definitely the fake samples will be very much, I would say, differentiated as comparable to the real samples. Means our discriminator model will be easily able to differentiate between real versus fake. So what will happen? The loss of this generated loss or discriminated loss will be very, very high. So what will happen? Again, the back propagation will happen. It will go back, update the weights, and this journey of training will keep on continuing till it reaches to a point where the loss will be minimum, right? Where the loss will be minimum. When we saying the loss will be minimum, it simply means that we are trying to convey that where the model or the discriminator model won't be able to differentiate between real versus fake samples. That's the whole point. I hope it is clear to everyone what I'm trying to convey over here. And this is the best way or best mechanism to generate artificial images. You must have seen nowadays, just by referring a textual data, how many of you have seen the tools like text to image generation, where whatever be the, like, you can just explain that what kind of image you want. Let's say I'm mentioning that I want an image of a person who looks like this, eyes are like this, nose is like this, whatever hairy curl hair, whatever you will mention, you will get the image of that specific part, and you will be amazed by the results. The image looks like that's just a human being, actual human being, which is currently existing, right? So that's the whole idea, how it is working internally, what kind of uh, internal architectures they're using. It's what we are discussing over here. Is it clear to everyone what I'm trying to convey over here? Similarly, nowadays, though, we do have the videos. I'm not sure how many of you have seen that, but nowadays, like in the reels, in the small uh, few minutes videos, you will be able to observe that people are directly copying the same, I would say, way of speaking. For example, my way of speaking, my way of gestures, hands, which I'm usually try to use whenever I'm trying to communicate something. Similar gestures, similar thing I can convey to the model. And there can be Priya V2, which is sitting over there, and maybe currently it is still working on, but you will be able to observe that we will be, after some point of time, won't be able to differentiate that whether the actual Priya is sitting or the fake Priya is sitting.
right? That's how we are progressing. uh, I whatever knowledge I have, I remember that I was talking to my senior a few days back, and he was saying to me that he was doing a postdoc from UAE, and he was saying that he was working on the project where they are trying to make a AI based tutor. And it's something where many people are doing a research nowadays, because I'm also in this specific domain. So I know that many of the bigger personalities who are working in this edtech specific domain, they're really working on to make those AI based tutor where, let's say, learner will try to provide the prompt that this is what they really want to learn from the tutor, and the AI based tutor will try to give you the explanation just like the way you want. For example, if let's say you are saying that I really want you to teach me like XYZ personality, maybe let's say Priya's way, so they will be able to teach you like that. So that is where the thing is going on. Maybe in future, after few years, you don't might require the actual human beings to teach you. I'm not sure what will happen next, but that is where the things are going on. That's what the research is going on. There is always a good and bad in those specific areas. The good thing might be that you will not be dependent on the timings of the session, or there will be a person who will be sitting for you, right? And as a human being, no one can spend 24 to 7 hours with you. But when you're working with machines, the beauty about machines is that they will not get tired. They will always have that flexibility to work with you 24 to 7. So if you are a night person, you can get the sessions at night. If you are the morning person, you'll get the sessions in the morning, and so on. But then comes the accuracy and the correctness, where the actual thing will lie, that whether the error will be minimum or not, whether they are teaching the correct concept or not. Maybe the base or foundations for which the mentors will always be there, and might be for the advanced concepts where students know the foundations, that whether it is correct or not, then those machines, those models will come into picture. I'm not sure, but this is what I usually think currently, right? So that's the overall idea about this GANs part.